Hello! Today we will tell you about the specifics of our measure, power engineering and electrical engineering, and how this is related to our future profession. We are going to do this by the example of one of the laboratory works in the discipline High Voltage Technique. But for a start, there is a little theory. When transmitting electricity over long distances, a number of problems arise, such as loss of electricity for heating wires, for corona discharges, breakdowns, and etc. To solve these problems when designing power lines, engineers carry out certain calculations and select appropriate components of power lines. And one of these components is an insulator, which is used to prevent breakdowns in high-voltage power lines. Alternating and impulse voltage are distributed unevenly across the insulators of the garland. If you do not take special measures on high-voltage lines 200 kV and more, part of the insulators in the garland can be so much energized that even under the operating voltage and normal atmospheric conditions, they will form a corona discharges, which is a source of radio interference, cause accelerated corrosion of fixtures and will cause additional energy loss. Let's look at an example of laboratory work. But first, we need to consider the electrical circuit of the installation in more detail. AT is an auto transformer, T is a high voltage transformer, RPR is a protective resistance, V1 and V2 are voltmeters, P is a spark gap, Dn is a voltage divider. In this experiment, we study the uniformity of the voltage distribution across insulators by the example of one of the 3D model laboratory works. This experiment consists of 3 stages in 3 different conditions. Stage 1. A shorting wire on 4th insulator in conditions when one of the insulators, in our case number 4, is defective. Stage 2. A leveling ring in conditions when the voltage drop across all insulators is the same. Stage 3. Under normal conditions when all insulators are free of defects. Now let's move on to the experiment. We determine the voltage at each insulator using a discharging stick. Then we need a shorting wire. Put it on the 4th insulator to make it defective. And then we make a circuit on the insulator under study and apply voltage to the garland until a breakdown occurs on the stick between the metallic balls. Let's see. We perform these actions for each insulator in the garland and calculate according to the formula the voltage drop across each insulator. This experiment needs to be done for all 3 stages. Here are the results for all experiments. In the first stage we can notice that the data for 4th insulator are missing, since the data couldn't be taken because of the defect of this insulator due to the shorting wire. At the next stage, we see the voltage across all insulators is approximately the same. third stage, all is okay. So I found out how the voltage is distributed across the insulator, and now I can choose the optimal parameters when designing power lines. All these things are part of our future profession. That's all. Thank you for your attention. We hope that you were interested in what we have told you about. With you was Andrei Smirnov from the Institute of Chemistry and Energy at Tольятти State University. Goodbye.